Okay, so the paper presented today. Okay, we are group 13, and the paper presented today is memory cache GPU scaling up and out key value store, and the authors are Taylor, Mike, Tom, and the paper is presented by Lijong Chen.
And Beta Toma. The overview of this paper is going to consist of the motivation, design, and main idea, which will further consist of the background, genome architecture, and memory cache GPU, which we'll go into later, and it'll close with the evaluation and the conclusion. The motivation for this paper, which is the practical, does that go into the practical theoretical?
Yeah,
that goes into the motivation, was it?
I think you can put it practical. I think you can put it here.
Okay.
Yeah, because with the numbers that people will think that is practical.
Right.
I think.
The motivation here's the motivation of the paper. It involves data centers. Data centers contain large numbers of servers, network hardware, memory, non-volatile storage, and cooling that, when put together, can consume tens of megawatts. Now, reducing energy consumption is essential if we want to keep data centers in perfect operation. U.S. data centers can use more than 90 billion kilowatt hours of electricity each year, and global data centers used roughly 416 terawatts just in 2016 alone, which, to put it into larger scope, is about 3% of total electricity used. And this consumption every 4 years will actually double. Now, they are also responsible for about 2% of total greenhouse gas emissions. That gives it the same carbon footprint as the airline industry. The 416.2 terawatt hours of electricity the world's data centers used was significantly higher than the UK's total consumption of about 300 terawatt hours. And then I'm going to add in some of things.
Yeah, I think we can stop here and see whether